welcome to your lessons on speed, distance and acceleration. This time we're looking at graphs, okay? So we're just looking at some do now questions, okay? So 5 little questions. I'd just like you to pause the video, answer those questions, unpause when you are ready to check your answers. So what is a scalar? Okay, so a scalar is something that has a magnitude only. Okay, a magnitude is just the size. Okay, number 2, what is a vector? Okay, so it's a quantity that has a magnitude and a direction. Okay, so our key one here is when we're looking at magnitude only, we're looking at speed or distance. When we're looking at magnitude and direction, we're looking at velocity or displacement. Okay, so talking about distance, what are the units for distance? Okay, so it's meters. And remember that's RES at the end, not ERS, RES. Okay, and that's an M. Time is in seconds, which is an S. Speed is in meters per second. Okay, and acceleration is meters per second squared. Okay, so let's put in meters per second and meters per second squared. Right, the equation linking speed, distance and time. So we get speed equals distance divided by time. And to calculate acceleration, we've got acceleration equals initial velocity minus our final velocity. So the change in velocity divided by the time for the change. Okay. So if you need to make any corrections, please make those corrections now, and then we'll move on to the next slide. Okay, so just a quick reminder, as we said, calculating speed, we've got distance divided by time. Okay, we can put that into our triangle if you wish. Okay, so we're going to put distance at the top, time, and then we've got speed. Okay, so we'd just cover up one of those and we'd be able to find it. Okay, a little bit more difficult for acceleration, so we've got v minus u, so our change in velocity, and then we've got acceleration and time. Okay, and we can pop that in a triangle as well. Okay, obviously you're not given the triangles, it may add a little bit of confusion. It may be that you're better off not using the triangle. Okay, right, so distance time graphs. Okay, so when we look at a distance time graph, okay, such as this one, it's got loads of different lines on there, and we can see that they're all labelled here. Okay, so the steeper the line, okay, so the greater the gradient, the greater the speed. Okay, because it's travelling a greater distance in a shorter time, or it may be travelling a greater distance in the same amount of time, or over the same. Over a short time period, it's travelling the same distance. Okay, so this is a less steep line. Okay, and so this vehicle isn't moving as fast, or this object isn't moving as fast. Okay, here we have a gradient of 0, and the distance isn't changing, so the speed for this line is 0. Okay, and then I suppose this would be the velocity, so we should really be talking about displacement here. The velocity is negative, it is returning back to the start, to its start position, 0 meters. Okay. All right, and now we have a velocity time graph. Okay, so I'm checking what the labels are here. Massively important. We've got units on this one as well. So from this we can make some calculations. All right. So with a velocity time graph, okay, if it's a diagonal line, there is a change in velocity because the velocity has changed from 0 to 40 for this part. Okay. So it's gone from 0 to 40. So the change in velocity is 40. That's taken 10 seconds. So we can calculate that acceleration. Okay. Here you can see the velocity is staying at 40 meters per second. Okay. So there is 0 acceleration. The gradient is 0. It is moving at a constant velocity. Again, we've got an acceleration because it is changing from 40 meters per second up to 60 meters per second. Okay. And that change has taken from 20 to 30 seconds. So we'd have to calculate the change of time there. Okay, so but you just do the end time, take away the start time. All right, so just for that little block. All right, we can draw that on. All right, so we can see it's gone from 20 to 30. And then finally, from 30 to 50 seconds, it's gone from 60 meters a second to 0 meters a second. Okay, so there is a deceleration. The time there is 20 seconds. We can calculate that by doing 0, take away 60. So you get minus 60, take away, divided by 20. Okay, and we get a minus 3. Okay, so all I've done there to make this more accessible is I've just broken this up into triangles and rectangles. Okay, so there's section A, section B, these two parts here, section C, and then section D. Okay, so it says the area under the line is equal to the distance travelled by the object. Okay, so for a triangle, the area equals half height times base. Okay, for the rectangle, area equals height times base. Okay, we can see the height is velocity and the base is time. Okay, and if we go back, we can see distance equals speed times time. Okay, for a triangle, okay, it's changing velocity. Okay, so we only want this area, this triangle area. If we do velocity times time, we get the rectangle. We only want half of that. Okay. So if we look at the example from that previous slide, okay, it's the same graph, okay, we can see how the acceleration is calculated for each part. You'll notice it goes A, C, D. There is 0 acceleration here because there is 0 change in velocity, okay? So you can pause this, have a look at those, look at how the calculations are carried out. It's just using the equation acceleration equals change in velocity divided by time. Okay, but remember, use the times for each side of the block. Okay, so this is 20 take away 10, this is 30 take away 20, and this is 50 take away 30. Okay, so that's 20 seconds for this part, 10 seconds for this part, 10 seconds for this part, and then obviously 10 seconds for this part. Okay, pause the video if you need to write anything down. All right, and now we're going to look at the distance travelled. Okay, so this time we have A, B, C, and D. Okay, again, we need to look at the time that it's taken. Okay, so this one for A, it's 10 seconds. Okay, again, B is 10 seconds, C, 10 seconds, D, 20 seconds. Okay, for this part, it's really simple, just the area of a triangle. Okay, area of a triangle. Okay, this part B, just simply an area of a rectangle. Part D, again, area of a triangle. Okay, it's only for part C where we have to do area of a rectangle plus area of a triangle. Okay, this would likely be a 6-mark question in your exam. Okay, they may ask you, so explain in as much detail as possible, showing the calculations, the journey of this object. Okay, you'll notice here it's given a total distance travelled. Okay, so adding up area A, area B, area C, area D. Okay, and from that we can calculate the average speed, which is the total distance travelled from here divided by the total time. Okay, so we get 34 meters per second. All right, so pause that, have a little look through, check the calculations if you wish. And then there is one here for you to practice. Okay, so describe the journey, this journey, in as much detail as possible. Give values for speeds, acceleration, and distances travelled. Okay, so first things first, it's a velocity time graph. Okay, second thing we want to do, we want to split that into 2 sections. Okay, so we've got section A, section B. Okay, so we need to think about what we're going to write. Okay, so for section A, think about the velocity. Okay, the acceleration. Okay, remember saying there's no acceleration is a valid answer. If it's staying at the same velocity, there's no acceleration. Okay, and we want to look at the distance travelled. Okay. Okay, again for section B, we want to do the velocity. Acceleration. and distance travelled. Okay, we should really talk about, when we talk about the acceleration, the time. Okay, so the time bracket. So for section A, I would say from 0 seconds to 20 seconds. The object travels at 12 meters per second. Okay, the acceleration is therefore 0 because there's no change in velocity. Okay, and then we can do over the 20 seconds, it travels 12 times 20 to give me the distance travelled. Okay, so 240 meters. Okay, section B, we do the same again, so from 20 to 30 seconds, so we're looking at 10 seconds. Okay, it decelerates from 12 meters a second to 0 meters a second in 10 seconds. I can then calculate the deceleration as minus 1.2, as we've got minus 12 divided by 10. Okay, and the distance travelled is just going to be using that triangle formula, so it's a half height times the base. So the height is 12 times 10, so we get 120. Times a half gives us 60. Okay, and then I can talk about the total area, so 240 for section A and 60 for section B. Okay, and that's going to give us a total of 300 meters. Okay, so just to prove to you that that's correct, we should have the same answer there. They've gone on to calculate the average speed, okay, or the mean speed. Okay. All right, so thank you very much for that. Please answer your OMG questions as well, and good luck.